Good morning, students. Today we will start the chemical reaction and equation. Right. First of all, we will see what is the chemical reaction. Chemical reaction is the process in which a new substance with a new properties is formed. It means in a chemical reaction, the reacting molecules lost its old property and acquires a new property. Right. During a chemical reaction, atom of the one element do not change into the another atom. Right. Only the rearrangement of atom takes place in a chemical reaction. Any chemical reaction have a two part, reactant part and product part. You are seeing this is a chemical reaction. In this, magnesium and oxygen is the reactant part. Both magnesium and oxygen undergoes a reaction and forms a new compound, that is the magnesium oxide, and this magnesium oxide is a product. Right. The bonding of magnesium in air to form a magnesium oxide is an example of the chemical reaction. Before burning an air, the magnesium ribbon is cleaned by rubbing with the sandpaper. This is because the magnesium ribbon have protective layer of the magnesium carbonate. To burn the magnesium, first of all, we need to remove this magnesium carbonate from the magnesium ribbon so that it burns easily. Right. The magnesium ribbon start burning with the dredging light with flame. Similar examples is there: soaring of milk, formation of the curd from the milk, cooking of food, digestion of food in our body, process of respiration, fermentation of grapes, rusting of iron, burning of fuels, burning of candles, wax, ripening of fruits, all are the chemical changes which involves a chemical reaction. Now, let's see, all the chemical reaction have some properties, some characteristics, right? The conversion of a reactant into a product in a chemical reaction is often accompanied with by some features which can be observed easily. These important characteristics of the chemical reaction are as follows. First, evolution of the gas means any chemical reaction could evolve gas during the reaction. Formation of precipitate, change in the color, change in the temperature, change in the state. Now we will see one by one. First, evolution of the gas. When zinc reacts with the dilute sulfuric acid, it evolves the hydrogen gas. Means this hydrogen gas evolves only when the zinc reacts with sulfuric acid. Right. Similarly, when there is a reaction of sodium carbonate with HCl, it evolves the carbon dioxide. Right. This shows there a chemical reactions is taking place. Now, second is the formation of precipitate. A precipitate is a solid product which separates out from the solution during the chemical reaction. For example, in a reaction between the lead nitrate and potassium iodide solution, a yellow precipitate of lead iodide appears. Means when lead nitrate reacts with the potassium iodide, it gives a lead iodide, which is a precipitate. This downward arrow sign is the symbol of precipitation, right? And this upward arrow is representation of gases elimination. Here the hydrogen is also a gaseous elimination. Now, when a silver nitrate solution mixed with NaCl, it gives a white precipitate of silver chloride. Right, you are seeing here when the silver nitrate reacts with the sodium chloride, it gives us silver chloride, which is white in color, and sodium nitrate. Similarly, when barium chloride reacts with the sodium sulfate, it gives a white precipitate of barium sulfate. It's a precipitate. It's a precipitate. Right. Now, come to the third point, that is the change in color. Some reaction also takes place with the change in color, right? Like rusting of iron. When iron reacts with the oxygen, it forms a brown color of iron oxide, right? Similarly, when colorless lead nitrate reacts with the colorless potassium iodide, it gives yellowish lead iodide, right? This appearance of yellow color and brown color shows that the reaction is taking place. Now, fourth one is the change in state. Some reaction accompanied by the change of state. For example, when a solid wax burns to form a water vapor and carbon dioxide are gases. When you will burn a solid wax, it gives you a carbon dioxide and water vapor, which is a gas, right? Similarly, when petrol burns, it gives a carbon dioxide and water vapor, which is also a gaseous form. Now, come to the next point, that is the change in temperature. Some reactions are accompanied by the change in the temperature, that is rise or fall in the temperature. Means during the chemical reaction, it may be possible that there will be a rise in temperature or will fall in the temperature. Like when a zinc reacts with a sulfuric acid, it gives a lot of heat. And hydrogen gas. Similarly, when you will react with a calcium oxide, which is also known as the quicklime, with the water, it gives a calcium hydroxide with heat, with the elimination of heat. This calcium hydroxide is also known as the slacked lime, and calcium oxide is known as the quicklime. This should be kept in your mind. This name, it might become in your objective questions. Now, let's come to the next topic, that is the chemical equation. What is the chemical equation exactly? Chemical equation is nothing but is a short form of the chemical reaction. When you like to represent any chemical reaction, you can represent it in the form of chemical equation. You just put the symbol of any reactant and product. I think I have already told you that any chemical reaction have a two part. One is the reactant part and second is the product part. Both part is represented in the short form, and that short form is the symbol of the elements or compound. Right. In the previous classes, we have already studied about lot of chemicals, lot of ions. Right. Now, all the chemical reactions can be represented in the two ways. One, in the terms of word, and second, in terms of symbol and formula. In terms of word, you just write the name of compound or element. See here, I have written a zinc is the element, and sulfuric acid is the compound. I have just written the name of these two, right? And when this zinc reacts with the sulfuric acid, it gives you a zinc sulfate and hydrogen. I have just mentioned the name of the compound formed after the reaction between the zinc and sulfuric acid, that is the zinc sulfate and hydrogen gas. Right, this is the product and this is the reactant. Now, second is the in terms of symbol and formula. This above reaction can also be represented in the form of formula, or you can say in terms of symbol. I have written here the symbol of zinc, that is the Zn, and symbol of sulfuric acid, that is the H2SO4. Right. When this zinc and sulfuric acid reacts, it gives you zinc sulfate, and hydrogen gas evolves in this reaction. Right. So you can represent all the reactions in two ways, either in the form of word or in the form of symbol or formula. But later on, you need to represent all the chemical equation in the terms of symbol and formula, because it is the easiest way to represent any chemical equation, and it will help you in the balancing of the chemical equation. Right. I think you all know that all chemical reactions need to be balanced, because we have to follow the law of conservation of mass. Right. Second is the balanced and unbalanced chemical equation. Any equation could be a balanced equation or unbalanced equation. If then question arises, what is the balanced equation and what is the unbalanced equation? Right. A balanced equation is the equation in which number of atoms of all the elements is not equal to on the both sides. But on the other hand, the balanced chemical equation is the equation in which the number of atoms of each element on the two sides of the equation are equal. It's called a balanced equation. Like, see here, in this equation, there are two hydrogen on the left hand side of the equation, and there is a 4 hydrogen on the right hand side of the equation. So this is an unbalanced equation, right? This is an unbalanced equation because there is only 2 hydrogen over here, and on the right side there is a 4 hydrogen, right? When you will put 2 over here, so now there is a 4 hydrogen on the left hand side and 4 hydrogen on the right hand side. There is a 2 oxygen on the left hand side and the 2 oxygen atom on the right hand side. Now this becomes a balanced equation, right? You are seeing here the atom of all the elements are equal on both sides. Here 4 hydrogen, here also a 4 hydrogen, here is a 2 oxygen, you are seeing here is also a 2 oxygen. So now this become a balanced equation, right? You need to balance all the equation because conservation of law of mass says that mass can neither be created nor be destroyed. Means the mass of the reactant must be equal to the mass of product. It can only possible when the number of atoms of all the reacting elements must be equal to the number of atoms of the products, right? Then question wise is how we can balance any chemical equation, right? So now let's study about balancing of a chemical equation, right? According to the law of mass conservation of mass, the total mass of product must be equal to the total mass of reactant because mass can neither be created nor be destroyed. This is possible only if the number of atoms of each element is equal on the two sides of the equation. Balancing of a chemical equation means making a number of atoms of each element equal on both sides of the equation, right? Now, what is the importance of the balanced chemical equation? The importance of balanced chemical equation lies in the fact that it satisfies the law of conservation of mass. That is, in a chemical reaction, the total mass of all the product is equal to the total mass of the reactants. Now, the question rises how we will balance a chemical equation. We can do it by hit and trial method. In this method, we will follow a different steps. One by one step, we follow the rules and we can balance any chemical equation. In the first step, write the word equation. First of all, you need to write the word equation, right? In the second step, write a skeletal chemical equation. In second step, you need to write a skeleton chemical equation, right? In the third step, count the number of atoms of a different element on reactant and product, right? In the fourth step, select the biggest formula to start balancing, right? Means you are seeing all the chemical formula of compounds. You can select the biggest formula of compound, right? First of all, predict that one, and in the fifth stage, balance the element of the biggest formula in an equation, right? Next, then balance the other elements. Now, in the last step, check the correctness of the balanced equation. Now, let's take an example, right? A steam is passed over a heat iron to form a magnetic iron oxide and hydrogen. You have to balance this equation. So first step is writing the equation in word form. Iron plus steam, magnetic oxide of iron and hydrogen. Now write the skeleton chemical formula equation. Iron, steam is the H2O, magnetic oxide of iron is the Fe3O4 and hydrogen is the H2. Now in the third step, count the number of atoms of each element and compound. Right, this is the element hydrogen and oxygen. Left hand side there is only one iron, right hand side there is a 3 iron. Hydrogen on the left hand side there is a 2 hydrogen and right hand side there is a 2 hydrogen. On the oxygen left hand side there is only one oxygen and right side there is a 4 oxygen atom. Now the biggest formula in this equation is the Fe3O4. So you need to balance first of all these elements, right? That is the iron and oxygen. So to balance this oxygen, I have just multiplied 4 over here to balance the oxygen. There is the 4 oxygen, so I have just multiplied 4 in the water molecule to balance the water. Now the iron is 3 over here. Iron is 3 over here. So I have just multiplied 3 in with the iron to balance the iron element. Now the remaining is the hydrogen. Here the hydrogen is 4 to the 8 and hydrogen is only 2. So I multiply 4 with this hydrogen to balance the hydrogen atom. Right? Now last one, to check the correctness of the balance equation. We are seeing here iron atom is 3 on the left hand side. On the right hand side there is a 3 hydrogen. Left hand side there is the 8 hydrogen, 4 to the 8. And on the right hand side there is a 4 to the 8 hydrogen. Oxygen, there is a 4 oxygen, and there is also a 4 oxygen on the right hand side. So now this equation becomes a balanced equation. So this was about the chemical equation and balancing of the chemical equation. Thank you.